Okay, so for these sorts of questions, you're just looking for ways to like reduce the amount of terms in the formula, right? And so to do that, we just try to use certain laws that reduce the amount of things in the formula. So for example, the complement law. Here you have two terms, you have a plus not a, and that can get reduced to just one. And so we need to also find ways to change the formula to be in a way where we can actually apply these laws. And so, first of all, some laws that you can think about, or patterns that you can try to recognize, are these ones. So if you have a, so a represents any expression, plus 1, that just becomes 1 by the domination law, because anything ordered with 1 is 1. And so this is domination law. It's not listed in the slides for some reason. Okay, another thing to notice, sorry, another thing to notice is that a plus 0 is just a, because the truthiness of this only depends on a. Other things to notice are that a and 1 is just a. This is called the identity law. Whoops. And the main thing about these sorts of things is that 1 over here just represents any formula that is always true. So if we had, for example, a and x plus, sorry, not x, this over here evaluates to 1 by the complement law. And so this thing over here becomes a and 1, which just turns into a. And so we've managed to use laws to sort of remove this entire thing from the formula. Okay. Another thing is that a and 0 equals to 0, because 0 and anything is just 0. Also, by the way, this thing over here is the unique law, as you can see over here. And so, for example, for this one, 0 represents anything that's always false. So if you had a and x and not x, because x not x is a contradiction, it's equal to 0. And so this entire thing turns into a dot 0, which turns into a. Okay, and the final thing I wanted to mention is a law that isn't in the slides for some reason, but it's really useful. So it's called the absorption law. And what this says is that if you have some formula or expression plus some other formula ANDed to that same formula at the start, is just equal to that formula, to the validity of that formula. So a plus something and a is just equal to a. And so let's think about why this is true. So what this is saying, like intuitively, is that the truthiness of this just depends on A. So it's saying that B has no bearing on whether or not this is true. So let's think about a couple cases. When A is true, what happens? So this is 1 because A is true. And then we have 1 plus something. And 1 plus anything is just 1. So when A is true, this is also true. So when A is true, this is 1. Okay, now what happens when A is false? We have that this is 0 plus, then we have a conjunction, so we have and, so we have b and something as 0. And anything and 0 is just 0. So this entire thing becomes 0. So what we notice is that this is true if and only if A is true, and this is false if and only if B is false, because no matter what B is, like it won't change the truthiness of the formula, only A will, and so this is equal to A. That's kind of why it works. You just kind of need to either memorize this or understand it enough to be able to think of it like on your own. Okay, so now moving on to the question. Just looking at this, the first thing to notice is that we have 4 terms, right? We have this one, this one, this one, and this one. And they're all connected to each other using pluses, which are like ors. Okay, so the reason I'm mentioning this is that if we look at this term over here, it's exactly the same as this one. So they're literally identical, right? And so if we look at the laws over here, we have that A plus itself is just equal to A. And so if we were to have that this thing was ORed with this thing, so plus, we could just remove one of them by the idempotency law. But the issue is that they're not together, right? We have something in the middle with pluses. And so we need to use associativity, which is the property that plus has. So like A plus B plus C is the same as A plus C plus B. So we can like move them around. That's like the point of this. And so we can just do that here. So let's move this one in place of this one, just like we did with this thing over here. So let's do that really quickly. Okay. So I'm just going to copy paste it because I can't be asked to write all that. Okay. Then we're just swapping the positions of the two things we mentioned earlier. So we're swapping the positions of these two. So let's just do that. Oops, that was a bit too close. Okay, we swap the positions. Don't forget the if and only if sign in between every step. And then we have to mention that we used associativity. Associativity of plus. Okay, and now we have these two things together. So we can use idempotency. So the law that A plus A equals A. So essentially just removing one of these two things. So let's just do that. Again, I'm just going to copy paste the line because it's easier. What the hell? Okay. Boom. Then we just remove one of them. Okay. So there we use that idempotency law on this thing and this thing. So we need to write that out on the right side to make it clear. Okay. So the next thing to do is to try and simplify this further, right? And so when you're trying to simplify things, as mentioned earlier, you should look for patterns. So maybe something like this, or something like the complement law, or the thing where you have like a contradiction. And so if we're to look at this, we need to think about ways we can turn this into something where we can apply one of the laws I just mentioned. So just looking at this, some things you can notice are that we have, for example, z here, z here, and z here. And so we could like factorize z out of all of these, but I'm not sure how useful that would be. Another thing to notice is that in one of the terms, this one, we have x and y. And in another of the terms, so this one, we have not x and y. So in this term we have like a, and in this term we have not a. So we have the contradiction of something else. And so it would be really nice if we could like have these connected in some way. So we can like have x and y plus or dot its contradiction. And so we can try achieve that by factorizing z out of both of these. That way we'd have this together with this. So let's try it. By the way, factorizing is just doing this in reverse. It's like the distribution law in reverse. It's just like in maths. Okay, so let's factorize z out of these two terms here. So doing that would give us z, and then, sorry, it's a bit messy, z, and it's a bit messy again, but z and x dot y plus not x dot y. Okay, so that's factorization. Then we can't forget the rest of the formula. Okay, let's just write that out. Distribution law slash factorizing, but without space. Okay, so now we have x and y plus not x and y. So we have a plus not a, where a represents x and y. And so we can use this law over here, the complement law, on this thing that we mentioned over here. Also, I should probably put this in square brackets. So let's just do that. So now we have z and 1 by the complement law. So complement law. Okay, now we have z and 1. So we have something and 1, which is just equal to that something. And this is called the identity law. So let's just do that. So that helps us get rid of the 1, which makes it a bit simpler. Now we have z plus all this other stuff. And here we use the identity law. Okay, now the thing is, you might look at this and think that, how do we simplify this further? We could try expanding the brackets, so distributing, but that wouldn't really get us anywhere. So you just need to look for patterns, right? So one thing to notice is that over here we have something, so a, so in this case az, plus some stuff. So let's just call the stuff b, so we have x bar and y, that's b, and it with z, so the same thing that was over here. Right? And this is really, it's the exact same thing as what we had for absorption law. So this is in the form of the absorption law. So just to reiterate, in this case, A is Z, B is this thing, and A is this thing. So it's in the form of the absorption law, and so we can apply it. So looking at this law, this entire thing should just be equal to Z. And so we can reduce this big thing into just Z. And that's it, that's the answer for the question. So this might have seemed a bit difficult to notice, right? But the thing is, if you just practice these questions enough, you'll start to see the patterns and just notice that you can apply these certain laws. That's all you need to do, just need to practice a bit more. Okay, so that's that question. Now we can move on to the other one. Don't forget to write out the fact that you use this law. Okay, on to the next question. Okay, so next let's do this question over here, which is actually from the same quiz that you got the other one from. Okay, so first thing I wanted to just mention is that if you see, for example, x, y with nothing between them, this is just the same as x and y. Just like how a, b, and like normal mathematics is just the same as a times b. So it's like the same principle. Okay, first thing to notice with this is that we have like two main ways of going forward. We could distribute this, or we could distribute the entire thing. Because remember, this isn't the only distribution law that exists. There's also this other one, which isn't in the slides for whatever reason. So it looks something like this. And this distributes to a plus b and a plus c. And we have the same pattern over here. So we have like this being a, x and not y would be a, plus, so plus, and then we have b and c. So in this case, the b is this thing over here, so not x plus y, and the c is z. And so this expression is in the exact form of this like law. And so we can apply it. We can distribute this using this and this. So let's just do that. That will give us x and not y plus this. So we probably need another set of brackets. Like so. And then we have that ANDed with the other stuff. So x and not y plus z. Okay, that's it. So here we apply the distribution law. Okay. Next, what we can notice is that we have something plus something plus something. And so we can actually just drop these brackets, which makes it a bit clearer. Okay. Next thing to think about is that in this one sort of term over here, we have x and not x, and we also have not y and y. And so we can probably do something with this term to get a situation where we have something with this negation. So for example, maybe x and not x. So we have x and not x, which would give us 0. Or we could have something like y plus not y, which would give us 1. And so having a situation where we have this would help us simplify this further because we can just reduce it to these things, right? So let's try do something. Just looking at this, we could maybe distribute this with this, or we could distribute y with that thing. So just like thinking about it in your head, if you were to distribute not x with x and y, you would have not x plus x. And so that would be good for us because then we can simplify it to 1. And so let's try distributing it and see where it takes us. So just as a reminder, we're distributing this with this. So that will give us not x plus x and not x plus not y plus y. So this looks really weird. Let me just rewrite it. There we go. This as well. What the hell is going on? Okay. And all this other stuff from before. So here we use the distribution law. Okay. So again, we have something plus its negation, and so we can use the complement law to reduce it to 1. So let's do that. It becomes 1, then and should be a square bracket. So this was the complement law. What just happened? Okay, never mind. And again, we have 1 and something, which can be just turned into that something. This is the identity law. So 1 and not x plus not y would just be not x plus not y. So we can just remove the 1, which gives us this. We have not x plus not y plus y with all this other stuff from before. So here we're using the identity law. Okay. Next thing to notice again is that we have something plus its negation. So we have y plus not y. And so we can just use the complement law again to reduce it to 1. So this just becomes 1. So then we have x, not x, plus 1. And this just becomes 1 by the domination law. Because remember that anything plus 1 equals to 1 by the domination law. And so we're just going to do this in one step. So we're going to remove this and say it's 1. So we have 1 and all this other stuff. So remember, first we use the complement law to reduce this to 1. Then we use the domination law to reduce the entire thing to 1. And so here we use complement, domination, okay, domination laws, okay. Okay, next we can again use the identity law because 1 and anything is just anything. So we can remove the 1 using the identity law. So this becomes x and not y plus z. Here we use the identity law. Scuffed handwriting, but still. Okay, and that's it, that's the answer to this question. So as long as you just practice enough of these questions, you'll start like noticing situations where you can apply different laws and find ways to get into like other situations where you can apply the complement law or the absorption law or just anything that reduces the amount of stuff in your formula. Okay, so that's it. If you have any questions, just let me know. Or if anything wasn't clear.